Hi guys, today I'll teach you guys about basic functions. Now, our learning objectives would be to use objects to find images, to use images to find objects, to use an object to find itself. That means when I substitute the object, I would get the exact same image. And to also use algebra to find other objects. Now, let's look at what a function notation is. Function notation is just a fancy way of writing normal functions. Now, this may be the notation f(x) to x plus 3. Notice that I have the colon and the arrow in a different color because that's important. And when we want to talk about the equation part, we only use the equation part when we want to answer questions. So if I were to convert this to the equation part, the two things that I've marked in red is going to change into brackets and the equal sign, because we know equations are things with equal signs where we consider both sides, left and right. We can also call the same function a different name. Let's say I want to use g, it would be gx giving me 2x minus 4, or you could use the same function. These are just examples of function notations, and then these are examples of equations. And this is how we convert them from one form to the other. If the exam asks you to leave the answer in the function notation form, this is what you will have to give me. Now, let's look at how we can use objects to find images. If you don't know what an object is, or if you don't know what an image is, I'll have a link in the description so that you guys can check that out. Right, so this is the question that you guys will encounter, an example. I've simplified it so it wouldn't take a lot of words, but basically they would have the same idea. Given the function of f(x) is x plus 3, find the image of 3. So in this question it says find the image. That's what I want. That means the 3 would be the object. Now, if I were to have the two sets, like how we understood the first part of functions, we know that this part is where all the objects are listed, and this set is where all the images are listed. It says here, find the image of 3. That means my 3 is an object. I am going to first label these two sets. This is going to be x, and this is going to be fx. Okay, I know that 3 is an object, so it's going to go here. How can my 3 be transposed? How can it be moved to my fx category? It has to plus 3, right? Everything in my x category, I have to plus 3. That's how I get to the other side. And I know in the fx category, 3 is going to map onto 6. Because 3 plus 3 is 6. The function says x plus 3, so all I have to do is just substitute that 3 in. But we don't want to answer every question drawing, these two sets, objects and images, over and over again. So this is the answer that you guys will have to give in the exam when you face a question like this, where they give you an object and then they give you a function. All you got to do is just copy that function one more time, and then I want to replace all the x's with my object, which is this place. And then I can see that this is just 3 plus 3, and that gives me 6. That's all. That's all you need to write in the exam, and this would give you your marks. What if we want to find objects using images? It's almost the same thing, but it's going to be a little confusing if you don't pay attention. Given a function of fx is x plus 3, I'm using the same function. Find the object of 6. Now, previously, we used 3 as the object, and then we used the same function fx plus 3. We find that the image is 6. This time, I want to find the object of 6. That means 6 is the image. So I'm reversing the process to show you that I'm going to get that 3. And I'm going to show you how I'm going to get it. So again, I will have two sets. This is the object set, and this is the image set. Again, I'm going to label them x and fx. Remember when we had 3 in this category, and we know that, for us to get to the other side, we have to plus 3, because the function is x plus 3. So this time, they have given us 6. Find the object of 6. So 6 is the image, 6 is going to be here. That means I want to go back to the previous set, the object set. If the previous set adds 3 to give me my 6, that means for me to go back, I'll have to minus 3. And that would be a 3. 6 minus 3 is just 3. But likewise, I don't want to keep drawing these two sets, objects and images, over and over again. So how can we actually write this? How can we give an answer when you're in the exam hall? Well, I would copy this, the same function, and I also know that fx, this place, is 6, right? The place fx is now 6. So I'm going to replace that fx with 6. And you can see that this is a solvable equation. 6 equals to x plus 3. And I can use this equation, 6 equals x plus 3, to get me my x, which is that original number that has given me the 6. So all I gotta do is just rearrange, and then I find that x is 3, which is exactly the same as the previous set that we have, the previous question that we have done. This time giving the image instead of the object. They're just opposites of each other. If you didn't get this, just rewind, go back to the previous question, understand that first, and then come back to this. They are exactly the same. It's just they're opposites of each other, right? Now, what if we want to use an object to find itself? For example, this is the question. Given the function fx is 2x plus 3. This is my function. Find the value of x if fx is x. There's a typo there. So find the value of x if fx is x. What does this mean? Again, we can revert back to the two sets to understand. I'm going to draw the two sets, and then I know this is the object set and this is going to be the image set. Of course, it's going to have more than one element. Again, if you don't know the basics, I would recommend that you watch my previous video and then watch this when you actually understand the basics. Right. So again, I'm going to label this as x, and I'm going to label this set as fx. It says here, this is the function, and it tells us to find the value of x if fx equals x. That means, according to this fx, I know that x is in my object. X is my object, and then in the end, I would have an x. What does that mean? I'll first place x in my object set, and then after I map to the other side, my answer should be also x. F maps x onto x. So that means my x would be mapped onto x. I'm looking at this second equation, fx equals x. So this is what it means. That means I want to find an answer where if I fit into fx, I should be able to get the same answer. So what could that answer be? We have to solve this algebraically. What I always like to do is I like to copy what the question has given me. For example here, fx is 2x plus 3. And then I also know fx is equal to x. So what I'm going to do is I'm going to substitute, just like the previous question, I'm going to substitute that fx with x, because fx is equal to x, so I can easily replace this fx with x. Now I can see that this x equals 2x plus 3 is an equation. I can solve this equation again, and I will have x equals negative 3. What does this mean? This means if I input negative 3 into this space, fx, if this x were to be replaced by negative 3, that means the 2x plus 3, that x would also be replaced by negative 3. And if I were to solve this 2x plus 3, where x is negative 3, I would still get negative 3. This means x is equal to x. Now let me show you what I actually mean, because I don't want to just say and expect you to be able to imagine. So I find that my x is now equal to negative 3. That means if this is negative 3, it's supposed to direct me back to negative 3. So let's see if this works. Alright, fx is 2x plus 3. So I'm going to write fx is 2x plus 3. And this time x is negative 3, and I'm supposed to get negative 3 on the other end. So let's try. F negative 3 equals 2. Again, this is going to be negative 3 plus 3. This simplifies to negative 6 plus 3, and indeed, yes, we have negative 3 on the other end. Therefore, we have solved this problem where fx equals x. This is a question where it won't pop out like this. Usually, the question would ask, find x where x maps onto itself. So this is the understanding behind what we want to do. All right, next slide. Okay, so anyways, we want to now use algebra to find the objects. This is the question. Given the function fx is x plus 3, find the value of p such that fp is 11. Okay, this is going to be a little tricky, but as long as we follow the basics, we should be fine. So again, I'm going to draw two sets. These sets are just for understanding. In the exam, you only need to copy what's on the right for every question that we've gone through so far. So this is again going to be my object set, and this is going to be my image set. I'm going to label these two, x and fx. Now it says here, this is my function, fx equals x plus 3. I'm using the same function as we've used for the first and second question. Now I want to find the value of p such that fp is 11. I want to look at this function now. fp equals 11. That means if I were to input p as my object, I would get 11 on the other side. So I'm going to key in that p, and I know that's going to take me to 11. Okay, so I have my relationship now. But the thing is, what number here, what number p would take me to 11? I know that p has to plus 3 to get to 11. So that means p would be 8. But you can't just tell me, oh, p is 8 by guessing. And in the exams, they wouldn't take this answer. They want an algebraic method. They want you to show me that you understand and you are able to manipulate functions. So let's see. I'm going to copy down the function, always my first step. Second, I am going to... Now, I know that this is a relationship. If my inside is an x, the outside would also be an x. I can actually change that x into a p. And my x would change accordingly, inside and out. If this x were to be a negative 3, this would also be a negative 3. If this is a p, then this would be a p. So now I can see that fp is equal to p plus 3. The question has also given me another fp. fp is 11, so I'm just going to copy that down. Now we can see that fp equals p plus 3, but at the same time, fp is also equal to 11. I want to focus on this side. This small part. I know that these two are equal, so that means p plus 3 and 11 must be equal. I'm just going to write them like that, and then now I can solve for p. And we know, from just looking at this, p is 8. Now let me just talk a little bit about this fp thing. If I have a 1 plus 4, we know that equals 5. And if I have a 3 plus 2, we know that equals 5. Because these two are equal, just like how these two are equal, I can write 1 plus 4 equals 3 plus 2. We know that this is correct. That is why I'm able to write p plus 3 equals to 11. Same concept here. Anyways, thanks for watching. Remember to like, share, and subscribe. That would be all.